Okay. So as far as like the airway stuff, that's gonna be more of a review today. I'm actually going to minimize this so I can put an upper airway here. Okay, so I'm gonna start with the left side, and then we'll go from there. So the blood from the left ventricle, where does it go?
Aorta.
It goes to the aorta, right? So we know that much. Try to keep it simple. Okay. Miguel, I don't think I picked on you yet. Miguel, so the blood that leaves the left ventricle that goes through the aorta, where is that blood going?
It
Doesn't go to
goes
shit.
to. It's not the lungs first.
I'll give you a hint. This is rich in oxygen. It has a whole bunch of oxygen. One needs oxygen. Not shit. What needs oxygen? The body needs oxygen, right?
Yeah.
To stay alive, to make ATP.
Which?
Alright, so all of this is going to be dumped into your body. So this is you right here. Your little EMT hat.
Oh,
right
you're
here.
asking like the specific blood vessels that was going into.
Oh no, I wasn't. So all of this blood that is rich in oxygen is gonna go to your body. So what's your body made out of?
Organs.
Organs. We'll say pancreas. That's the pancreas. Mia, what are organs made out of?
Tissue.
Tissue. Nate, what is tissue made out of?
Cells.
Cells. And what happens in the cells that we care about? What is that oxygen gonna do in the cell?
Exchange, right? Or in the cell?
Yeah, in the cell.
They make, and then they make the
In the mitochondria, what do they make you?
the ATP,
The ATP, perfect.
and then their babies are the CO2.
The
Or
placenta.
the placenta, my bad.
So this is hotel cell.
You weren't here yesterday, don't look at me crazy.
What you worried about his life? She doesn't know how to do shit.
She looked back so fast, like.
Well, we started with like heart and lungs, and then I heard placenta. I'm like,
You said it's so good.
He's talking about a metaphor.
Yeah.
Okay, so right here at the tissue level, we're gonna dump off that oxygen, right? We're dumping off that oxygen, where eventually it's gonna meet glucose in the mitochondria of the cell. And what are we picking up right here?
CO2.
I'm picking up CO2, good. CO2. Okay, so from here, these capillaries, well, first off, to kind of make it a little simple, or break it down more, this aorta is going to break down into individual what? Arteries. As those arteries get smaller, so it can actually feed the tissue itself, what are those arteries gonna be called? Arterioles, good. And then finally, down when we get to the actual tissue, to feed the actual tissue, they turn into what? Capillaries. The same capillaries that are around your alveoli are the same capillaries that feed the tissues. So capillaries. I just put caps, like capillaries won't fit. All right, cool. So these capillaries, they do the thing, they drop off the oxygen, and now we're picking up the CO2. So these capillaries on the other side will eventually meet and make slightly bigger vessels that are called what? Arterioles. Remember, in the medical field, if the tube gets smaller, the name gets longer. Arterioles. Then these arterioles would combine to make bigger vessels. I'm sorry. Venules. Yeah, venules.
I was confused. I was like, what?
Nah, venules. That was my bad. Venules. Remember, I'm dyslexic. Venules. All right, these venules will combine to make bigger vessels called what?
Veins.
Veins, there we go. Okay, if the blood is coming, the blood that's been used up that is rich in CO2 and low in O2, if that blood is coming from the lower part of your body, all of these veins will combine to make a really big vein. What is that very big vein that's gonna bring that blood back to your heart called? The inferior vena cava. Cool. What if that vein, the vein that's coming from the top part of your body, what is that one called? Cool. Okay, so now, again, we're CO2 rich, CO2 rich, CO2 rich. So this, what is this called, this chamber? Right atrium, good. This one is going to fill. When it gets full enough, it's going to squeeze, all that blood's gonna get squeezed down to your right ventricle, called RV. Now your right ventricle is gonna get full, and when it gets full enough, all that blood is gonna get squeezed out through what vessel? What is this vessel? If it pushes blood away from your heart, it's a what?
The pulmonary artery.
Pulmonary artery, good. So since it's pulmonary, where is that vessel going to? And what are we gonna do in the lungs?
Gas exchange CO2 for us.
Exactly. That's what Maddie was talking about. So now going here. Again, CO2 rich. CO2 rich. Okay, so now we're dropping off all the CO2 because of that thin membrane. What is it called when something is leaky, when something can seep through something?
Perfusion.
There's another word I'm looking for. Permeable. So the membrane is so thin that it's permeable, it's leaky. That means that it's gonna allow the CO2 to get pushed in. And so that thing that Maddie was talking about diffusion, as all of this blood that's coming back to your lungs is rich in CO2. So because there's so much CO2 on the blood side and so little CO2 on the alveoli side, that it's just gonna push that CO2 into the alveoli. And it has to be equal. At the same time, all the oxygen that's in here is rich in oxygen, waiting to get pushed in. All of this is gonna get pushed into the capillaries. So it becomes an equilibrium from high concentration to low concentration. So now that we picked up that oxygen, where's it going to now? So now these capillaries picked up the O2, dropped off the CO2. And now where are we taking this blood that's now rich in O2? Pulmonary vein, good. And we're gonna take it where to?
Back to the heart.
Back to the heart. What side of the heart? Left atrium, exactly. Going to the left atrium. You guys remember this, so that's good. It's gonna get filled. It's gonna push that blood down to your left ventricle. And from your left ventricle, after it gets full, and again, this side is rich in O2. This is the oxygen side of the heart. This is your CO2 side of the heart. It's gonna get pushed out through your what? Aorta, to your what? Body, to your organs, to your tissue, where you're gonna have perfusion down to your cells, and that is the vicious cycle of life. That's how life happens. Now, down here at the cell level, when Mr. Glucose meets Miss O2 to make ATP, what is that called? What kind of metabolism?
Aerobic.
Aerobic metabolism with oxygen. Any questions? That's pretty much it. You sure? No question?
Oh, sure, lots of questions.
Ask, go ahead.
I just can't think of them.
Okay. All right, guys. You guys have any questions about this crack, the airway? Then what we'll do is we're gonna go into the BVM skill.
So going back to that question, so intrathoracic pressure.
Okay.
When they're talking about it, they're talking about pressure going outward, not coming.
As far as like how it affects the
As far
blood
as the
pressure.
thoracic cavity, so when they say intrathoracic pressure, are they talking about pressure being externally applied?
So when you have an increase in intrathoracic pressure, so that means the pressure is increasing in the thoracic cavity.
Mm-hmm.
When you have that, that's talking about us forcing air into the system. Usually the way air comes into your airway is by negative pressure when the diaphragm pulls down. Usually when air comes in, it has to be because of negative pressure. That's the way the body's built. But if we're forcing the air in, that's the opposite of how it usually functions. So now we're pushing the air in instead of it being pulled in. We're pushing it in. So now we're increasing the pressure in there. So if we're increasing the pressure in there, we're taking away from the negative pressure. And that what that negative pressure does, it does two things. One, it helps bring air into your system, right? That negative pressure. Two, that negative pressure helps with preload. Preload is just the blood that comes in from the system. So every time that diaphragm that's down here goes down to make that negative pressure, it's going to help bring in, to maximize the amount of blood going into your atrium and into your ventricles. So if we're pushing blood in, if we're pushing oxygen, air into your airway, now we're taking away from that negative pressure. So we're minimizing the amount of blood going into your heart.
So I guess with the question though, it was they're gonna experience reduced blood pressure.
They're gonna reduce, yeah, they're gonna,
Because the veins are actually getting, if it's reduced, you would think they would be expanded. Because you would think it would create, because if our hose is getting smaller, you would think that would create higher blood pressure. If the hose was
So
getting
you're talking
bigger,
vasoconstriction versus vasodilation.
Yeah.
so
so
don't
that's
don't
what
worry
I'm
about the
getting
vessels. Just worry about, like, it's not really that. Worry more about like the blood being sucked into the heart. Like that negative pressure helps suck air into your airway, but it also helps kind of bring in that
Kind
blood.
of catapults. That negative pressure is going to help push so that that blood can get through.
Bring
Versus when we're breathing for somebody, it's
so it has
positive
nothing to
pressure.
do with the.
Yeah, it's not like a dilation problem.
or-
Yeah.
No.
Yes.
No.
Basically, just don't have enough.
But I like your thought process behind
Yeah.
that.
Does that make sense?
Kind of.
It's like trying to fill up this.
Well, we have a whole cardiac
Yeah.
chapter, and
Well, I'm just
hit-
thinking about the actual pressure itself and how that's affecting is, like I said, the veins or the arteries.
It's really just affecting the blood being pulled
Just the
from
volume.
the veins down into the chambers.
Yeah, so
That's
without
what
negative
it's-
pressure, we're not going to have that little kick that's actually going to be able to push the blood into the atrium.
The
So
extra
we're
bit,
gonna
yeah.
have, we don't have any pressure to kick it, so we're not gonna have that same force that blood's being drawn through. So we're not gonna have the same amount that's being drawn through, so our pressure is gonna go down.
We'll cover it again. Yeah, cardiac. It looks like a visual.
Think about it like the box being a passive.
Alright, would you mind going